mas maraming ulan at mas malalakas na bagyo. Ito ay ilan sa mga nararanasan bago mag-umpisa ang El Niño.
Hindi maging kasi hindi. Mas malala pa ang El Niño sa basahan.
El Niño and La Niña are weather patterns found in the Pacific Ocean that can affect weather worldwide. These are two opposing weather patterns that break the normal conditions in the Pacific Ocean, where trade winds should blow west along the equator, taking the warm water from South America to Asia, causing an upwelling. As warm water is replaced by cold water rising from the ocean's depths. El Niño and La Niña episodes typically last 9 to 12 months, but some may last over a year. These weather occurrences do not occur on a regular schedule, but on average, they occur every 2 to 7 years, wherein El Niño occurs more frequently than La Niña. Each occurrence of one of the two triggers disruptions in normal levels of temperature and precipitation. Such disruption could cause changes in air movements in the tropics, triggering a cascade of global side effects. El Niño events are associated with the warming of the central and eastern tropical Pacific, while La Niña events are the reverse, with a sustained cooling of these same areas. El Niño originates from the same Spanish term which directly translates to the boy child. It was first used by Peruvian fishermen to describe the appearance of warm ocean currents off the coast of Southern America that usually occur during Christmas. The phenomenon happens when the trade winds in the equatorial Pacific weakens, causing less water to move to the western areas, therefore causing the central and eastern areas of the Pacific to be warmer than usual. During El Niño, jet streams tend to shift to the south, causing wetter and colder weather conditions in the southern parts of the United States. Meanwhile, El Niño causes warmer and drier conditions in Asia, Australia, and India. This effect could reach as far to the continent of Africa. The drier and warmer weather heightens the risk of forest fires and smoke haze in the regions mentioned. From past periods of El Niño, it has been recorded that it has produced droughts in southern Africa, parts of India, Indonesia, Australia, and certain regions of the Americas, floods in Kenya, Argentina, and the United States, erratic monsoons in South Asia, and extremely high temperatures in Japan and some regions of Canada. La Niña, on the other hand, directly translates from the Spanish term as well to little girl. La Niña is also sometimes called El Viejo, anti-El Niño, or simply a cold event. In simple terms, it is the direct opposite of El Niño. During occurrences of La Niña, trade winds are even stronger than usual, pushing more warm water toward Asia. Off the west coast of the Americas, upwelling increases, bringing cold, nutrient-rich water to the surface. In this case, the jet stream shifts towards the north, leading to warmer and drier conditions in the United States and cooler, wetter weather in parts of North America, especially the Pacific Northwest parts. Weather conditions in Australia and Asia are projected to be wetter than usual. In its past occurrences in Asia, La Niña caused numerous deaths due to persistent rains it have caused. In the year 2016, the Philippines recorded an estimated $325 million worth of damage and production losses in crops when it faced an 18-month-long occurrence of El Niño. The Department of Agriculture recorded loss of crops, including rice, corn, cassava, and high-value crops such as banana and rubber, amounting to 1.48 million metric tons. This affected 413,456 farming households in the country, belonging to 16 out of 18 regions the country has. The phenomenon caused reduced rainfall, resulting in droughts, dry spells, and stronger typhoons. This occurrence lasted early 2015 until July 2016, and this is the last El Niño occurrence recorded in the country up to date. According to National Geographic, La Niña is a climate pattern that describes the cooling of surface ocean waters along the tropical west coast of South America, a phenomenon wherein some parts of the world it causes increased rainfall, while in other regions it causes extreme dry conditions. La Niña events sometimes follow El Niño events. La Niña increases rainfall. On May 2016, rainfall increased by 31% in Luzon, 41% in Visayas, and 19% in Mindanao. There was also an increase in crop pests and diseases brought by flooding in low-lying farm areas. La Niña may also elevate the instances of landslides, specifically in the country's eastern seaboard. This phenomenon is the magnifier of storms, which leads to floods, flash floods, and landslides. This was felt when we had severe tropical storm Maring, with its international name, Compasso. This brought too much destruction in agriculture and infrastructure and took plenty of lives. In 2020, La Niña worsened the effects of Typhoon Raleigh in October and Typhoon Ulysses in November, which devastated the Visayas and northern Luzon respectively. This was confirmed by Esperanza Cayanan, Deputy Administrator for Research and Development of Pag-asa. La Niña's damage reached up to 82 billion pesos. The effects of La Niña to watersheds and water supply may vary depending on the area. La Niña is characterized by lower than normal air pressure over the western Pacific. Thus, these low pressure zones contribute to increased rainfall. La Niña is brightening the water supply potential of Angat Dam in Luzon. The rain brought by La Niña will help increase the water supply for the customers. So, without the La Niña, our dams won't have enough water. In Indonesia, over 50,000 people were affected due to floods when a river overflowed in East Java. On the other hand, La Niña is a climate pattern that usually delivers more dry days across the southern third of the U.S. Its drought-producing effects are especially pronounced in the southwest, but the phenomenon will also contribute to higher risks of hurricanes as the winds help the storms build. During La Niña years, winds push warm water west. When the ocean's temperature changes, even just a few degrees, the way it interacts with the atmosphere changes too, and this can affect weather all around the world, as rain clouds form over warm patches of the ocean. Paul Degunski reported for the Los Angeles Times that for the United States, La Niña causes uncharacteristically dry and warm weather in the southwest, but stormier and colder conditions in the northeast. Higher temperature means more severe droughts, wildfires, and water shortages. On a lighter note, La Niña can have a good effect on the fishing industry of western South America, because the deep water brought to the surface is often rich in nutrients. Coastal upwelling supports the growth of the seaweed and plankton. These, in turn, provide food for fish, marine mammals, and birds. During El Niño in the Philippines, average rainfall is usually decreasing, 14% in Luzon, the northern island chain, 21% in Visayas, the central island chain, and 35% in Mindanao, the southernmost island chain. This means El Niño creates water shortages, hence water in crops are scarce. There was a study showing 1 degree increase in sea surface temperatures during July to September is associated with a 3.7% decline in irrigated dry season production. El Niño and La Niña are examples of oscillations that have a greater impact on our climate with effects that are perhaps surprisingly felt all over the globe. This warming in the oceans caused by the winds to diffusion of this warming all over the globe. It changes atmospheric pressures, thus contributing to rainfall, change in wind patterns, and sea surface temperatures. In this phenomenon, El Niño reduces hurricanes. Ocean temperatures in the central and eastern tropical Pacific Ocean are warmer than average, and rainfall is below average over Indonesia and above average central of eastern Pacific. In addition to what was mentioned, the impact of El Niño and drought is being felt throughout the region. In the Pacific, El Niño-induced droughts depleted freshwater supplies. The El Niño Southern Oscillation, or ENSO, phenomenon greatly affects the Philippines. The Pampanga River Basin is the fourth largest basin in the Philippines and has two dams within the basin, the Pantabangan Dam and Angat Dam. During the 1997-98 El Niño, the low water level in Angat Reservoir resulted in a high amount of manganese content of water being delivered to households. Increased precipitation during La Niña occurrences, as well as the stronger typhoons brought about by El Niño, could affect watersheds in terms of sediment yield. As more water strikes the land surface of the watershed, sediments get carried away to the channels, which could affect the water quality of the water supply in the watershed. In terms of its effect in water budget, in a study conducted by Dr. Rex Cruz and his colleagues in 2003 with regards to the effects of El Niño and La Niña on the water budget of watersheds in the Philippines in terms of surface runoff, there were no noted changes in terms of rainfall activity in both El Niño and La Niña occurrences in the four watersheds observed for the study. However, rainfall variability for both events were noted to be different in comparison with years, wherein no phenomena regarding both climate conditions happened. With concern to surface runoff, decreasing patterns with the values were observed during El Niño occurrences, but nothing significant was observed for La Niña.